Hello everyone, welcome to today's class. This is teacher Simon taking you through IGCSE Core Mathematics paper 0580/334 May June 2025, and this is part 2 for question 16 to 24. Now question 16 is coming from bearings. The scale drawing shows a path from S to P. 1 centimeter represents 2.5 kilometers, that is our scale. And they're saying work out the actual distance between S and P. So all you have to do is to get your ruler and you measure here. Okay, so what is our PS? Now what happens is that all of you do the same paper, okay, in the final exams. So the papers are printed on the same paper, so they have the same scale factor of enlargement. Now when it comes to our printers, if you are to print out this paper, then and you say maybe fit to printer margins, so you find that the paper is reduced a bit such that it can fit in the width that the printer can print, especially in A4 papers. So in that case, you are not going to have the same length of this PS, okay? So what you measure is what you write, okay? But the answer they give in the marking scheme corresponds to what you get exactly if you sit for that original paper, okay, that is brought in the exams. Okay, so if we try to measure here, mine here is, so if I can zoom this one, you can see that it is 6.6, isn't it? 6.6. So if it is 6.6, but in the scheme you might find something different. So in the scheme it is this is PS, so PS is going to be, in the scheme it is 6.5, okay, but mine here is 6.6. so you write what you have gotten, but these are centimeters, then we shall get the 6.5, then times the 2.5, times the 2.5, then this one will be in what? Kilometers. 6.5 times 2.5, that is 16.25. So 16.25. Then part B, measure the bearing of S from P. Mark this point from P, so you go to P. Now for bearings, for them they remain, okay? For them they remain. It is only these lengths which change, okay? Because here the principle that is being applied is the one for similarity of figures. So similar shapes have the same corresponding angles, but the lengths are connected by a scale factor of enlargement, or they are in the same ratio, okay? So if you get the length of maybe the bigger shape divided by the corresponding length of the smaller shape, then it's going to be equal to any other lengths that are corresponding when divided. You see that? Okay, now next they have told us, of course, to measure the bearing of S from P. So you need to get your protractor. So my protractor is here. We take it to P. They said from P, okay? So we bring it here on P. Remember, we measure bearings from the North Pole, and then we move clockwise. So we have to make sure that this one coincides with that arrow on the North Pole, and then we read clockwise, okay? We measure bearings from the North Pole clockwise. So if I try to zoom, then you can see that it is 142. So when I'm zooming here, first look at what we are having here. I'm supposed to, since I'm beginning from this side here, then to go down here, the 0 must be here. then we go down. So we are using this inner scale here based on mine. Okay. All right. Now, when I try to zoom again, you can see that it is 100 and what? 142 here. So our answer is going to be 142. And if your bearing, when you measure, the angle is less than 100, then you begin by writing a 0. So this is 142. Because bearings, we always write them to 3 digits. Okay, I said bearings are measured from the North Pole clockwise. Okay, then part C, E is 20 kilometers from P on a bearing of 0. So do you see here? The angle here is below 100, but instead of writing 70 degrees, they have written 070. So bearings, if they are below 100, because from 100, that is where we get the 3 digits, you begin by writing a what? A 0. Okay. So on the scale drawing, mark the position of E. So we need that position EP. If it is 20 kilometers, then we have, since on this diagram we are using centimeters, we have to divide through by this 2.5 kilometers. In a 10, we have 4 2.5, so this one will be 8 centimeters. Then we shall get our protractor again, and then we measure. We shall measure the what? The 80, not so? I mean 70. So you put your protractor again at P, and then you make it what? Stand such that it goes clockwise. We have to be moving clockwise, just like that. Again, I'm using the inner one because the 0 is here, then 70 is here. So now you get your ruler and then you draw through the 70. Then after that, I can remove my protractor. Then I have to tell the examiner that this is actually 70 degrees. And then I'll get my ruler here so that I can measure 8 centimeters from P here. So 8 centimeters, where are they? We can see they are here. Okay, so put a mark there, and then I can put off the ruler. Then I can rub this part here. It's not necessary now to have it. And these are 8 what? Centimeters. What are we marking there? We are marking point E. So this is E here. So that is how it is going to be. Question 17 is coming from transformation part A. They are saying Sue describes the single transformation that maps shape A onto shape B as a translation by the vector 7,1. Explain why Sue is incorrect. Let's look at A to B. Now from A to B, this is 1, 2, 3, 4, 5, 6, 7. Okay, then there is 1 down. So the translation vector is supposed to be 7 units to the right. Remember, x is positive going to the right, negative going to the left, and y is positive going up, then negative going where? Down. Now, when we write the translation vector, the top number is the x, okay? Then the one down is the movement in the y. So if it is positive, we move this way. If it is negative, we move left. If it is positive y, we move up. If it is negative, we move down. Now, here, since we moved to the right, okay, this is positive 7, okay? And then this one, we moved down. So it is supposed to be negative 1. But this person has 7, 1. So if you put 1 here, that means this person moved up instead of moving down. So what shall I say? We shall say that Sue moved up, or we say 1 unit up instead of 1 unit down. As simple as that. Okay, then part B, they are saying on the grid, draw the image of A after rotation of 90 degrees anticlockwise about 0, 0. So 0, 0 is the center of rotation. Now, in descriptions, when they are telling you to describe the single transformation that maps this onto that and it is rotation, they always give 3 marks. The first mark is saying it is rotation, then telling us the angle and the direction, that is another mark, and then about, this one is the center. That is how we describe. Okay, now what we do here, we can use a protractor or a tracing paper. Use a protractor or a tracing paper. Now, since I don't have a tracing paper on my software here, I'm going to use a protractor. So mark the point 0, 0. 0, 0 is here. Then we need, we rotate it to 90 degrees anti-clockwise. So I'll put my protractor here. This is my protractor. I'll put it at this position 0, 0. Okay. Then I can, we are moving anti-clockwise. So anti-clockwise, we move like this, not so. If it is clockwise, we move like that. So I'll put my protractor like this. Now I'll connect this protractor to each of these points here on A. Now look at this line here. It is passing through the what? The diagonals. You see? Those are 2 diagonals. So 90 degrees is here. You see that? So I'm also going to look out for 2 diagonals. So we have one here and then one here. So that means the image of this one here is going to be at this point here. Are we there? I mark that one. Then next, I do the same. I go to this one here. I connect this one here. Then look out for 90. 90 is here. Are we there? Now, this one here is a diagonal in 2 boxes. Then even here, I will go a diagonal in 2 boxes here. So that means my image is going to be here at this point. Okay, then next, I also continue. I put it on this one here. So this is a diagonal in how many boxes? 1, 2, 3, 4. That's a diagonal in 4 boxes. Are we there? Again, look out for the 90. 90 is here. Then a diagonal in 4 boxes. It will be here at this point. So I will draw it here. That is where I'm going to have it. Then next, we have this one here up there. So this one is a diagonal in how many? This is 1, 2, 3, 4, 5, but 2, 2. It's a box like this. Okay. A diagonal all through those 10. Okay. Now look out for the 90 degrees. Then move a pair. This is 1, 2, 3, 4, 5. So it has to be here. You see that? So I will have my image here at this point. So I'll put off this one here, then connect all of these points. You draw them using a what? A ruler. Like that. I can even shade it so that it becomes very clear. So like that. But then this one, they didn't tell us yes to label, but to be so systematic in your work and very smart, I can just put that is part B. It makes the work of the examiner very easy. Can just look at it and then gives you the marks. Then part C, describe fully the single transformation that maps triangle A onto triangle C. I've already said look at the number of marks given. If they are 3, then that is rotation or it is enlargement. But since we have done rotation here, this one cannot be what? Rotation again. And if there are 2, you look at reflection and translation. Because since it is, if it is translation, then you are going to say translation by vector, this. So saying translation is 1 mark, giving the vector is another mark. Then reflection, then you tell us the middle line. Reflection in the middle line. So reflection is 1 mark, and then the equation of the middle line is another mark. Then when it comes to rotation, just like I said, you tell us it is rotation, then you give us the 90 degrees or the angle and then the direction, then the other one is the center. If it is enlargement, you tell us that it is enlargement, then you give us the scale factor and then the center of enlargement. You get that? Okay, now let us look at this one here has to be enlargement. Now for enlargement, the object and the image are of different sizes, okay? But for the rest, if it is rotation, if it is translation and then reflection, the object and image are congruent shapes, okay? This one is the same size as this. You can see after rotation, even this one is the same size as this, you see? Okay, now we are seeing A1 to C. These ones here, you can see that C is bigger than A, so that is enlargement. So what do we do here? We draw lines through object points and image points, okay? Where they meet is the center of enlargement. Then let me write it here actually. Then we also need to find the scale factor of enlargement. How do we find it? Scale factor of enlargement. There are 2 methods you can use. One is you get the object image. No, it's the image. Image side length. Then you divide by the object side length. So what did they multiply in the side length of the object to give you the image? Or you can look at image distance from the center of enlargement, then divide by the object distance from the center of enlargement. You see? Okay, now let's draw these lines here. You get your ruler. This one here corresponds to this. So I'll connect this to that. Like that. Then another one is here. Connect it to this one here. You just draw all through, okay? These lines will meet anyway. Now they have already met. You see that? But I can continue and draw all of them. So this one and this one here, they will also meet there. You see? Even this one and this one here, they will also meet here. All of those lines are going to meet at the same point. But since we have done this one in here, what we need to do is to make these lines dotted. Yeah, you make them dotted so that you don't interfere with what was there. So that is that. Now here where they meet, you read off this one is -5, and then this is 7. So we are going to write, this is enlargement. So the first mark is saying it is enlargement. Okay. Then by the scale factor, you give the scale factor of enlargement, right? The scale factor dash, then center, or you can say about, just like the way that one was given. The center of enlargement, we have seen it is -5 and then 7. Isn't it? Yes, -5 and 7. Now to get the center of enlargement, we get the the scale factor of enlargement, side length of the image. This is 2 units. Divide by the corresponding side length, that is 1 unit. So you get 2. Okay? Even if you use this one here, which has 4, then divide by 2, you get 2. You see that? This one has 3 plus 3, 6, divide by 3, you get 2. So that means the scale factor is 2. And also, one other thing that is very, very important, it is the sign of the scale factor. If the scale factor is positive, that means the object and the image are on the same side of the center of enlargement. So the center of enlargement is here. Now these two are on the same side. But I can have the object here and then the image is this other side when they are on opposite sides. That means the scale factor of enlargement is going to be negative. Okay? And if the scale factor of enlargement is a whole number, then the image is going to be bigger than the object. You can see this one is bigger than this. Scale factor is positive 2. So if the image is smaller than the object, suppose this was the object and this is the image, then the scale factor of enlargement is what? A fraction. Because you will say image side length is 1 over object side length is 2. So don't you think you are getting a fraction? So that is that. So for this case, we are having the scale factor of enlargement what? Positive. But where we have the scale factor of enlargement being a negative, that one is so common in what? In extended, not in core here. Alternatively, we said you can find it using the scale factor of enlargement. You can find it using the image distance from the center and then divide by the object distance from the center of enlargement. So what do I mean? I'm going to use just one of them, okay? Let me use this one that goes through. Is it going through the diagonals? No. How about which other one? Maybe this one here. So I want you to look at the distance of this one from the center. It is not passing through any diagonal. Actually, from here, the other corner point it passes through is this one here. It's the same thing also here. So that means image distance from the center, I'll take this one where it is passing through the what? The corner point here as 1 unit. Okay, I take it as 1 and also this one as 1. So from here up to here, those are 2 units. Then divide by from here up to here, which is going to be 1 unit. So you still get what? A 2. So that is that. But better use image side length divide by object what? Side length. Part A, they are saying points C and D lie on a circle. Write down the mathematical name of the line CD. Now, CD is a line that doesn't pass through the center of the circle. Usually, they represent the center of the circle with a marking of O. Okay? They label it with O. But it is not there. Just like you see in part B, the center is O here. You see that? So this one is called a chord. So this is a line that connects 2 points on the circumference of the circle and does not pass through the center. Then the one that passes through the center of that circle is what we call the diameter. Okay. The next part B, they are saying the diagram shows a circle with center O points KLM lie on the circumference of the circle. Draw the triangle KLM so that KLM is 90 degrees. Okay, so I can say maybe this is K. Okay, K. Then L, you're saying is there, and then M. Now, if this one is 90 degrees, you should know that one of the circle properties is that angle in the semicircle is always 90 degrees. So this one here, I must have the K, then this is, let's say, this has to be the M. So this has to be the diameter. KM has to be the diameter. That's why they put for you the what? The center. So when I connect this to the circumference of the circle, then I should get what? The L there. It has to be 90 degrees. This one is coming from this theorem here, that if this is angle at the center, then when I look at this point here, then I connect it to the circumference and also come here. This angle here is actually half the angle that is at the center. In other words, angle at the center is twice angle at the circumference. You see that? And this one is 180. So 180 divided by 2. What do you get? Don't you get 90? So if this one is 180 degrees, then this one has to be 90. So angle at the center, let me even write it here. Angle in the semicircle. Angle in the semicircle is always a right angle. So because of that, KM must be the diameter. So you draw it passing through the center of the circle. So it doesn't matter where you put L, so long as K to M passes through the center. So I can put my L here. I can put wherever I put. Okay. So just because I'm putting my L here, it doesn't necessarily mean that it has to be here. Are we there? Okay. So make sure that you pass it through the center. Then when you do that, that one, you mark this one as M. Then you can connect. Please use your ruler when you are drawing these lines here. So that is that. Then I can put this one as 90 degrees. So that is what we are supposed to have there. Question 19 is coming from graphs. Part A, complete the table of values for this reciprocal graph. So y is equal to 20 over x. Wherever there is x, I put the what? I'm going to put these values. So, of course, 20 divided by 3. This one is a recurring decimal. So it is going to be 6.6 recurring. So I can say 6.67 maybe. And then 4 here. 20 divided by 4, you will get a 5. Then 5, 20 divided by the 5, you get this 4. Okay, so that is what we are having there. Then on the grid, draw that graph there. So we have 1 and 20. 1 and 20. It is here. So we have two types of plots. We have a dot and a circle, and then that cross. So you use the one that is good for you. But for me, I like what? The circle. The dot and the circle. And when you are drawing, make sure that you don't draw this big one like that. Okay, now when I try to reduce, I take it back here. Then you don't draw something like this. You put a dot and then you put a big circle. No. It looks ugly. Make sure that that circle doesn't touch here, doesn't touch this way, and then there. You see? So we shall have it drawn just small like that. Then next we have 2 and 10. 2 and 10. Then the next one here, there's going to be, let me first draw 4, 5, and then 5, 4. So 4 and 5, and then 5 and 4. So when you look at our scale here, one small box will be equivalent to 5 over 10, which is actually 0.1. 5. It is the same also here. Also, no, it's not the same. So here we are having one small box is equivalent to 1 unit. Not so. They are adding on 1 unit, but then we are seeing 10 small boxes all through. So this one will be 0.1. Now, x is 3. If x is 3, then y is 6.67. So this will be the 6.5. Okay. 5.5, then 6.5. This will be 7. So maybe it is around there. So I'll put it just near 7, something like that. And then we have 5 and what? We have 5 and 4. So it has to be just 2 small boxes below the 5. That is what we are going to have there. Then you join all of these points to produce a smooth what? Curve. Now, before you join these points here, first look through all the questions underlying this whole question. So we can see that there is this one here. Use your graph to solve the equation, this one here. In the exam, you have to show how you solve this from the graph. So what do you have to do? First, you are going to cheat the examiner like this. You get the 20 out of x is equal to 8. Solve it, okay? You are going to get 20, which is equal to 8x. And then your x is going to be equal to 20 over 8. That means x is equal to what? 2.5. Now in the exam, when you write this one here, and it is seen on your graph, on your paper here, it is going to be crossed. So you use this to cheat the examiner. Now, this one here, what is given is actually our y, which is equal to what? Now 8. So we are supposed to draw a line y is equal to 8. So where it meets with the curve, that is our solution. Are we there? Okay. Now, since you are not going to draw the same graph, they are going to give you a range of values here, okay, within which your value must lie. Now, what are we going to have here? You go to your graph and you look out for these coordinates. These 2 coordinates here, 2.5 and then 8. You mark that point. So 2.5 is exactly in the middle of what? 3 and 5. Then 8, this is 6, 7, 8. So we shall have something like this here. I think it is here. So you mark that point. The point is here. So I'm making it small. Then from there, you make sure that when you are drawing, you pass through that point. These ones, you rub them off. They shouldn't be seen anywhere. Okay? Now let us connect these points. Make sure that we pass through this point here. So I will try to have a graph like that. Okay? Then you draw that line y is equal to what? Y is equal to 8. This is the one, the line. And then since you have just drawn that line, in order not to interfere with the curve that you are having there, you make the line what? Dotted. So this is y, which is equal to 8. And this one here is for 20 out of what? X. Now, from here, you have already cheated the examiner that the answer is 2 point what? 2.5. Okay, so, but they are going to give you a range of what values. So for you don't write the 2.5, yet when you come to the graph here, your answer doesn't correspond to this one here. Okay, so it has to be corresponding. So that is how you cheat the examiner. So 8x is equal to 2 point what? 0.5. Okay, so the range that is actually given in the scheme is this one here. If your answer falls within, then you are okay. It is 2.45 to 2.55. They give you that allowance because you might draw the curve when it is like that, So that is that. Question 20. A spinner is numbered 1 to 5. Rinesh spins the spinner many times. He works out the relative frequency that the spinner lands on each number. So they are saying if it is landing on 1, we can say how many times. So maybe they were 20 times. Then divide by the total number of times the spinner was spun. Then it gives you this value here. Okay, that's what we call relative frequency. You get the frequency, then divide by the total number of times the experiment was done. So complete the table. To complete the table, we know that total probability for any given distribution is always equal to what? 1. So that means to get the probability of a 3, it will be 1, then minus all of these other probabilities. So we have 0.15 added to 0.22, added to 0.26, then added to 0.25. So 25 plus 15, that will be a 40. Okay, so that is 0.40, then 0.62, then 88. So that is 1 minus 0.88, which gives us what? 100 minus 88, don't you get 12? So that will be 0.12. Then part B, they are saying Rinesh spins the spinner another 1,500 times. Calculate the expected number of times the spinner lands on it too. So expectation, we get the number of times the experiment is done, then times the probability. Okay, so NP, it is spun 1,500. Then the probability of obtaining a 2 is actually 0.22. So 0.22. When you put this in the calculator, what do you get? 1500 times 0.22. That is 330. As simple as that. Those are the expected number of times you expect your spinner to land on it too. Question 21 part A. These are the distances above the surface of the Earth of 5 satellites A, B, C, D, and E. Each distance is in kilometers. And they're saying these are the ones, the numbers given. Write these distances in order starting with the shortest. So now what we can do, this one is given as an ordinary number. This one is in standard form, ordinary number, standard form. So we need to write all of them the same way. So I can write all of them as ordinary numbers. So you move 1, 2. So this will be 7, 8, okay, then 0. Then this one is 1, then 5. So 1 cancels 1 here, and then we add on 5 zeros. 1, 2, 3, 4, 5. Okay, then this one will be 2, 0, 0, 0, 0. Okay, so which one is the smallest? The smallest one has to be this one here, D. The next one has to be B here. Then the third one, this is 35,800. This one is 20,000. So it has to be this one here. Then the fourth one has to be which one here? This will be the fourth one then. And then the fifth one will be this C here. Okay. So, but you don't write these ordinary numbers. These other ones you have changed. You use the ones that are given. Okay. Okay. So they're saying write these distances in order. So we have 5, 3, 5. If they had said letters, I would have put a D. Okay. Then next we have 780, but that one is 7.8 times 10 to the power of 2. Then the third one is this one here, which is 2 times 10 to the power of 4. The fourth one is 35800. And then the fifth one is 1.5 times 10 to the power of 6 here. Roman 2, the radius of the Earth is 6370 kilometers. Satellite A is k times farther from the center of the Earth than satellite D. Show that K is equal to this, to 2 decimal places. If this is the Earth, okay, the radius of the Earth is this one here. So we have something like this. In fact, let me try to draw something here. This is the Earth, and its radius is 6370, okay, kilometers. Now they are saying satellite A is K times farther from the center than D. So A is far away compared to D. So I can have maybe A is here and then D is here. You see that? So that means from here, the center of the Earth, what did they give here? These are the distances above the surfaces of the Earth. So the surface of the Earth is here. So we can look at this length here and this one here. So this one here is what? D. 535. This is 535. And then from here to here to A. A is what? 35,800. So if they say K times satellite A is K times, then I'll get the distance of A from the center of the Earth. Then I divide by the distance of D from the center of the Earth. Okay, so I will have 35,800. That is from the circumference of the circle here of the Earth, but there is radius here. We are talking about the center. You see that? So that means we shall add that 6370. Okay, then divide by this one here. We shall have 535. We also add 6370. You see that? So what we get here is our answer. 35800 plus 6370. Then we divide by 535, then plus 6370. So we get 6.1 whatever. Okay, I can say 6.11. 6.11. Okay, hey, actually this is the one, 2 decimal places. So that K is the one that is equivalent to that 2 decimal places. As simple as that. Then part B, a satellite travels at a speed of 27,000 kilometers per hour. Find the distance the satellite travels in 95 minutes. Now, distance, speed, and time are connected here. Okay, so we are given the speed, we need the distance. So the one that you need is the one you cover. So distance is equal to speed times time. Okay, distance is equal to speed times the time. Now, if the speed is in kilometers per hour, then that means that the speed has to be in kilometers, time has to be in hours. Okay, so the speed is 27,000, time has to be in hours. So the 95, you divide it by 60. Then altogether, what do we get? 27000, then times 95 divided by 60. We get 42750. 42750. As simple as that. Then part C, a different satellite travels at a speed of 25,200 kilometers per hour. Convert this into meters per second. Now we know that 1 kilometer is equivalent to 1,000 meters. Then 1 hour is equivalent to 60 minutes. not so? But each minute is equivalent to 60 seconds. So that means this one is 3,600 seconds. Now, if we have 25200, these are kilometers. And then if we say per hour, then that is 1 hour. Are we together? Okay, now, kilometers, you convert them to meters. So wherever there is a kilometer, then I'm going to put what? I'm going to put 1,000 meters. Then wherever there is hour, I'm going to put what? 3,600 seconds. So what do we get when we simplify? 25200, then times 1,000, I'll add on 3 zeros, then we divide by 3600, and that is 7,000. So our answer is going to be 7,000 meters per second. As simple as that. Question 22 is coming from 3D shapes. They're saying the diagram shows a solid cylinder with height 10 centimeters. The volume of the cylinder is 478 centimeters cubed. Then part A, find the radius of the cylinder. Okay, so when you go to the list of formulae that is given in, I think it is on page 2, you'll find the formula for the volume of the cylinder. But every time you cut a cylinder like this, okay, you'll find that you see this circular part. So to find the volume, we get the cross-sectional area, which is going to be this area of the circle, then times this. So that means volume of the cylinder is going to be equal to circular base, that is pi r squared, then times the height here. So when you come to this list of formulae on page 2, you see volume of a cylinder. It is here, pi r squared what? H. So this is 478, which is equal to pi. We don't know the radius, but we know the height is 10. That means r squared here is going to be 478. We divide by 10 pi. Okay, divide by these other constants here. And then after that, we shall get the square root of this 478 out of the 10 pi to give us our r. So to 3 significant figures, what do we get here? Square root of 478 divided by 10 pi. The answer is 3.90. 3.90. That is 3 significant what? Figures. Remember, 0 is a significant figure if it is in between other what? Figures. Okay. The next part being, the cylinder is made from gold, and they are saying the density of gold is 19.3 grams per centimeters cubed. Calculate the mass of the cylinder. So right from here, I can cross multiply to get the mass. So mass is equal to density, then times what? The volume. Now the density is 19.3 and the volume was given as 478. I want you to look at how they set these questions. Do you see where they wrote the volume? Then after they put part A and part B. So these two stem from this one here. You see that? So that's why we are using that 472. So when we put in the calculator, what do we get altogether? 19.3 times 478. That one will be 9225.4. 9225.4. Question 23. The diagram shows a right angled triangle. Whenever you see a right angled triangle, if only lengths are involved, then we can use the Pythagoras theorem. And then if there is an inclusion of an angle, then we can use our acronym SOHCAHTOA. That gives us the relationship between the trigonometric ratios, okay, the sine, cosine, and what? Tan. Now, h here is the one we are supposed to find, so we have to use Pythagoras theorem. So using Pythagoras theorem, what are we going to have here? 35 squared plus 22 squared is equal to h squared. That means h will be equal to the root of 35 squared plus 22 squared. So what do we get? Square root of 35 squared plus 22 squared. That is 41.3. To three significant figures. As simple as that. Then question 24, which happens to be the last question. The diagram shows the right angle triangle. Now we see an included angle. So that means we are going to use what? SOHCAHTOA. SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent out of hypotenuse. Tan is equal to opposite out of adjacent. You see that? Now, relative to this angle here, this side here, the side which is far away is what we call the opposite side. And then the side that is perpendicular to the opposite side is what we call the adjacent, the side that is even near to the angle. And then this one will be the hypotenuse, the longest side of the, we call it the right angle triangle. So opposite and adjacent, that will be tan. That is the TOA we are going to use here. So tan of 52 degrees is going to be equal to opposite, which is y, out of adjacent 18.4. Meaning for us to get y, we just cross multiply, and this will be 18.4, then times tan of 52 degrees. Okay, so what do we get? Like I've always said, always look at the mode of your calculator. It has to be in degrees. Okay, so you can see a D on my pop-up display. So we have 18.4 and then tan 52. So this one gives us 23.55 or 23.6 to three significant figures. However, if the calculator was, let's say, in radians, how do we turn this to radians? We press shift, then mod. Then radians is option number 4. So suppose someone maybe gave you the calculator when it is in the radian mode. So when you press this one here, 18.4 then times tan of 52 and you press equals, you are going to get a different answer. You see that? It can also be in the gradient mode, shift mode, and then we press 5. There is a G on that pop-up display. Do you see it? Now, if I press equals again, do you see that I'm getting another answer? So you have to make sure that your calculator is in degrees. Press shift, then mod, and then degrees is option 3. Put it there, then press equals here, and then you get your answer, 23.6. That is 3 significant figures. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.